Yeah, thanks. Before I start, we've seen some pretty amazing talks today already, right? I don't have any drinks for you, and no robots. Oh, cool. Yeah, actually, some water would be nice. But anyway, so I do have something else just before we start, because I brought my camera to yesterday's party, and so I have a little sneak peek for you guys. Anyone has not been there? One. You slipped. No. Wait. Damn it. So it's too dark, damn. That was some nice games. I guess it's hard to see, but it gets better once I manage to switch the video. Not sure. The thing is, I just copied the video into the browser window, and now it is stuck somehow. Hang on a sec. So yeah, just one more, which I think was nice. Could we turn on the lights? Sorry, Tom. Is he here? But yeah, so we had a good time. So did Tom. And now I'll restart my browser and start with the talk. No, too much. Sorry, okay, I'm done. So, yeah, let's get to the talk. Let's call this talk is called Not Your Unit Test, which means it's not about unit testing, but I'll come to this in a second. My name's Alex, I'm a programmer, and I do a lot of Ruby and also more and more JavaScript. And I'm a big fan of CouchDB, just so you know. I work for and own a company in Berlin called Upstream Agile. And I also run a co-working space, which many of you have seen already, because that was the place all the JSConf people went in the days before the conference, that office, somewhere there. So this talk is about something called BDD. Just a quick hands, who knows what that is? Huh? I'm sorry. Okay, so BDD is behavior-driven development. Oh, sorry. You're hard to hear. And so, yeah, anyway, so what is behavior-driven development? It's a lot of things, just some random quotes about it. It's kind of an evolution of TDD, which is test-driven development. It's about getting the words right, communicating with the business side of things, and writing software that matters. And so what does that all mean, right? I mean, this is kind of the business side of the whole thing. So it's not about coding, or not just about coding, but also about business. But since we're a programming conference here, I'm going to talk about the coding stuff. And so the question here is, what's in it for us coders, not just for the business? And what I want to show you today is a few things that we can benefit from BDD, and that's you can improve your design process, the way you design your software. You can have less bugs in your software, which I guess is always good, and you can use some cool new tools, which will then again help you with the other two. So, in December last year, I started a little side project called Cobot, which was intended to help me run my co-working space because I hate accounting and all that stuff. So I just wanted to make that a bit easier for me. And actually I need to switch my resolution again because that just isn't working here. Sorry. Is that still correct? Yeah. Sorry about that. And so I started this little project, and I had a bunch of ideas, which are these. So I wanted to like automate some accounting and other things. And so how do I turn that into software, right? I just had some few ideas on how would I start and turn that into something that works. And there's a few approaches to this. One is called the functional specification document, which kind of means you sit down for a few months and write some documentation about your software, and then you at some point start coding according to the documentation, but then that's outdated already, and so it's called the waterfall model, and that doesn't make a lot of sense to me. Also, my company has the name Agile in it, so I'm kind of not allowed to use that anyways. And so there's another approach which is called InsideOut. By the way, the feature that I'm discussing here is now the payment tracking, so co-workers in the co-working space, if you don't know what a space is. So people can rent a desk and then I pay for it every month, and so I need to make sure they actually pay me and check who has paid me and who hasn't. So that's kind of the thing we're gonna develop now. And so this InsideOut is kind of programmer's favorite approach, because you get to do all the interesting stuff first, so you kind of design your database schema if you have one, or if your database requires one. You can check out some cool plugins and methods and all that stuff, algorithms that really is kind of interesting to programmers, right? And so you could come up with a few models, so like, okay, I'm gonna need users and memberships and something in this application, and then you say, okay, I need some methods on those. And you kind of start coding from the bottom. You think, okay, I need this and this and this and this, and I'll just start building up. And when I'm done, I'll just put a user interface on top. The problem with that is that it might end up like this. So there's a certain disconnect, right? I need to get my timing better. So you start from this kind of description, oh, I need payment tracking, which is way at the top, or if you will, from the left side of the bridge. And then you have your implementation coming from the other side, and then they kind of need to connect in the middle, and you just hope that it'll all work out, but it's really hard to do this because you're working from those sides. And so there's another approach that you can do, and that's called outside in. And that's actually encouraged by BDD people. And how it works is that you start with a feature description, and that's kind of it has a little formalized format. And so how it looks is you start with this, you're kind of first describing the feature and sort of the business benefits and what it's supposed to do for your business. And the business is there to make money, and so the benefit should always kind of end up in making money or saving money for the business. But that's the business side, as I said, so we're not going to worry about that too much. Instead, we're starting with giving it some context. And that works like this. And so you're saying, okay, I want to check those payments now, and suppose I have a new coworker and he hasn't paid me anything yet. And then I say, okay, so in my system that I want to test now, there's a co-working space in my software. So I said, give him a run a co-working space co-op, which is the space I run. And then, okay, I guess I should be logged into some kind of management console so that I can mark that person as paid or not paid. And then I need an example coworker. So we have Joe here. And so this is kind of the context of my test case. And next, I'm going to need some event. So what happens? And that looks like this. So I say, okay, there's a page or a list of coworkers somewhere. So I go to that list, and I click on Joe's name, and then I click on the current month, which in this case is September. and I press payment received. That's what I want the interaction with the software to be, right? And then at last, I want some outcome. And in this case, that's as soon as I press that button, the page should say, okay, now he's paid me, everything's cool. And so that is how you start BDD, with a high-level feature description that kind of describes what you want your software to do in natural language, which is really nice because it's easy to understand. And also, as it happens to be, this is a pretty nice starting point for our implementation, because we can run this. Even though it's natural language, there's a tool called Cucumber. How many people know Cucumber here? Not too many, good. So Cucumber, you can see it here already. So the black thing is supposed to be a shell. So I've typed in Cucumber, and then this features / track payments feature. That's the file I put my description in. And when I run this, it's going to tell me, oh, undefined step. And it gives me sort of this example down there, which I can paste into my editor right here. And so what this does is it maps natural language to code. And as you can see here, so it has given, and then there's a regular expression that matches. I run a co-working space, and then quotes and a matching group. And Cucumber will match every line in that feature description to those steps, and then it'll pass the matching groups into the function I give here. So here it says function name, so I get the name, which in this case would be co-op. And then I can run some code. So in this case, I want to save my co-working space in my database so that I can set up my test scenario with my software. And then next step, I'm logged in, so I need to do set some cookie or something, whichever my web framework requires, or actually go and fill out the form or do basic auth, whatever. There's another step, given a coworker, so I save that guy to the database as well. And then there's also what's this line when I go to the list of coworkers, and there's actually a predefined step in Cucumber, and you can map sort of descriptions of pages, so the list of coworkers, and you can map that to an actual URL in your application. So in this case, I map the list of coworkers to localhost / coworkers. And so run that again, and it looks a bit better, because now we are in red-green land. And we can see a few things are working already, so I kind of create that co-working space, and I'm logged in now, and there's this coworker Joe. And then at the fourth line, it says I can't go to that list of coworkers because it doesn't exist, right? And so what we have here now is a failing test, which is awesome, because now we can do TDD / BDD. And we do that by kind of moving in. Now remember, we're doing outside in, so we're on the outside now. We're moving one step in, and one step in this case would be kind of the HTTP layer interface, so kind of your web app controller, whatever level. And so since we're testing, we're not implementing that yet, we're writing a test case. This is all pseudocode, so but it should kind of work like this, right? So you could use something like Vals.js or Jasmine or so to write this test. And so now we're in code level and we're writing a test. So it says here, it should load all the coworkers. So we're kind of, just implementing some tests that it checks if the database is being asked for the coworkers. And then there's another one that checks that the response that comes back is actually a success. So the state is 200. And then we have that, and then we implement that, which will probably look something like this if you're using Express, or something else, not really that interesting here. And so we run that again. And so, we're once again on that list of coworkers, and it still doesn't work. We have the page now, but there's some error in the database. So we have to fix that as well, and there's a view missing in the database, so I need to write a test for that as well. Run it again, and now that works. And then the next step fails, so I want to click on Joe's name, and that doesn't work. And so I keep going, right? I mean, you get the idea. It's just normal TDD, test, fail, pass, and so on. So yeah, that's kind of the outside-in thing. So you start with the feature description. You describe what you want your software to do, or how you want to interact with it. And when you've got that, it's pretty much filling out the blanks, right? You're just running the tests, and it tells you what to do next. Oh, this isn't working. Okay, write a test for it, fix it, next. And also, what's pretty cool is that you know when you're done, because as soon as everything's green, you can stop coding. Instead of just keep working on and on and on, and just adding stuff, you have a clear goal where to go, right? And when you're done. And so what that means is that the design you're going to come up with is probably a very simple solution that just does what the feature describes and not anything else. Also, a nice side effect of that is that you have a pretty good test coverage. Since you're writing your test first, you're literally not writing any untested code, because you always have a failing test before you're implementing it. And so you also have those kind of multiple levels of confidence in your code, because you still have those unit tests that you know from traditional TDD. By the way, how many people here do test first? A few. Okay. So yeah, so you have those if you do it, and then you also have these kind of high-level tests as well, these cucumber scenarios. And that tell you that your different layers still work together, because I mean a unit test only tests like one method or one object, but what you really need, if you have like a stack that web apps have, you need to make sure that your different layers still fit together. So you have the database, maybe app server, and then HTML and the client-side code, and all that. And just getting back to this example that we saw here, you might have noticed we're clicking on a link here. And so how does it do that, right? It clicks on links. So yeah, it can. And so the answer, how that works, is there's a bunch of cool tools now. So we're at the next section of my talk. And those tools are, or can be these. So first of all, what you can do, of course, is just parse HTML using some XML parser, find the link, and then parse out the href and do that. What you can also do is use a headless browser, like, for example, HTML unit. That is written in Java, and it's sort of a complete browser without the GUI. So you can run it from the shell and tell it what to do. And it works kind of well. It has a few quirks and bugs, but you can work with that. And if that doesn't work, or you need extra testing awesomeness, you can actually use a real browser. For example, Selenium is a tool that allows you to run or to script a browser's behavior. So you can tell a browser from your test what to do. Click on that link, hover over here, do that. And it'll do that, and you can run assertions against that and yeah, test your app. There's a little problem with these tools. The more sophisticated they get, the slower it is. So running a Selenium test takes ages, versus just parsing HTML obviously is much faster because it's just in process, right? On the other hand, you get much more features if you're running a real browser, because you can also test for browser compatibility issues and that kind of stuff if you're using that. And if you're only using that headless browser, it's just, well, it's not the real thing, right? So if the real browser behaves a bit different from this one, then your test won't catch it. And so you kind of want to use these three all together depending on which scenario you have. If you have Ajax, you need to use at least the headless browser. If you just have static HTML, you can use the inline HTML parser. And so the good news is there's a tool called Capybara. How many people know that? Okay. So Capybara is pretty cool because it allows you. So it's a tool to run all these others. So it's kind of an abstraction that runs all these inside of Cucumber. The downside for you guys is that it's written in Ruby, if that is a problem for anyone. So the step definitions I showed you actually are not really true because you're going to be writing Ruby in those, which looks a bit different, but it should be readable, right? And so yeah, what you can do is just tag this scenario here, which you can see add JavaScript, and then it'll run in a browser. And so you have full stack testing, which means you can test anything you want, client-side, server-side, doesn't matter. The app is well tested, and you have no more bugs, of course, at least not so many. So back to my little project I was talking about. So my initial idea was I would be spending about 4 weeks on it because I was just using it for myself to make my own life easier, right? And so it would be really simple, and I wouldn't add much, and it would be cool. Turns out I was totally wrong on that, because we started offering that to other spaces as a service. And instead of 4 weeks, I know 8 months, almost full-time in that. And we've added tons of new features and had to change some designs and swapped out code in the code base. And so it grew a lot bigger than it was intended to be. And for that kind of changing software, unit tests don't really help you anymore. Because, I mean, you still need them. But as I said, you're not covering the interaction between your layers in those tests. So if you're changing one layer, the unit tests on that layer are still working, and also on the others, but your software is still broken, so you still need to test that. And so what you really need is a field of cucumbers, aka Cucumber Test Suite. And so the advantage that you get here is that it's totally implementation independent since it's natural language. That means it's very stable. And you can literally swap out your entire code base and replace it with something else. And those tests are still the same, which means you can run the new software against the same tests, and so make sure that you didn't break anything. And so that is pretty cool for that kind of stuff. Yeah, it's a huge safety net. 3 minutes, okay. So big safety net gives me courage to refactor everything I need, and this way I can keep my code clean, extensible, maintainable. That wouldn't have been possible without those tests. I would keep breaking stuff again and again. And so in this way, I also have a nice picture here. I can avoid the ugly spaghetti monster. I need to be quick now. So tools, just to recap. Cucumber allows you to write tests in natural language, and then you write those step definitions, which is to map the natural language to the implementation. Capybara is written in Ruby, allows you to drive all these tools that can run your tests in different environments, from browsers to just in process, whatever you want. You can use those kind of BDD unit testing tools like Vals.js to test your code on a unit level. And there are 3 main benefits from doing this. First of all, you have this outside-in approach, which means it drives the design process, which makes the design simpler, and it helps you to focus on what's important and what you need and when you're done, and you know that. You have that massive test suite, which is good, and also it's just not unit tests, but also these Cucumber tests that test your layers and the interactions. Yeah, that's what I just said. And also these tools allow you to test the whole stack, including client-side, JavaScript, server-side, everything. That gives you the confidence to refactor your code so you can keep it clean and avoid the spaghetti monster. And that's it, pretty much. Thanks. How much time do I have left? It's not all over. So anyway, thanks. That's my talk. That's a bunch of links. And also this one on the bottom is an actual open source project where you can see how that really works. That was a bit abstract right now. Question? What? Written? What's what the... No, I didn't paint that. That was her. Anyway, since I'm running out of time, one last thing. Who feels like this? Honestly. Okay, come on. I know if you do. Just one piece of advice for you. Start writing shitty tests. That's the only way you're going to start testing. You're never going to start being good at it from the start. Just write it. They're going to suck. Delete them. Write better tests. You get better at it. And that's it for me. Thanks.